Hello, good day everyone. Welcome to Learners Hub once again. My name is Bolaji. I'm your online instructor at Learners Hub. If this is your first time coming to my YouTube channel, please hit the subscribe button and click on the notification bell. What that will do is that anytime I post a new video, you will be alerted and be informed that a new video has been posted. So you'll be one of the first person to watch and learn from what I've posted so far. Our video today will be a continuation of what we started yesterday on estimation, what we started previously on estimation. In our previous video, I made a video explaining how to go about estimation, doing estimation, and I gave a list which I tagged as the item list. I said the item list will be produced in two stages, for the substructure and for the superstructure. And I went further by saying that we'll be starting with the substructure first, where we try as much as possible to explain how to estimate site clearing. We first went ahead to explain what site clearing is, and we further went ahead to explain how estimation is being estimation for site clearing is being done. It was explained that site clearing can be estimated using two methods. You can either estimate site clearing with the intention of clearing the entire site, or you estimate site clearing for just clearing just a portion of the place where you are going to have your building, with the inclusion of a working area. Today, this video is going to be a continuation of that process, where we'll be explaining further on. We'll be picking one of the list we have, and the next item on the list we have, which is setting out. I'm pulling up the list now. This is the list we created for estimation of the substructural items that we have. Don't forget that the drawing we are using for our estimation is this one I just pulled up. Is this one that I just pulled up. And it is the drawing of the construction that is ongoing on one of our sites. This is the same drawing that will be estimating the material that we needed for. In our previous video, we have estimated site clearing as the first item on this our list. Now the next item on this our list is setting out. I remember explaining that setting out it does not have a particular method of estimating, or a particular way of estimating the quantity of setting out, because it's not a quantity per se. It is an activity that you just attach a fixated amount of money to, which is the reason why the units read sum. It is just something that is negotiated based on what is the activity that is to be carried out, and a certain fixated amount is apportioned to it, then it is done. But be as it may, since setting out is not a quantifiable, so to speak, mathematically quantifiable item, the activity involves the use of some materials which are quantifiable, and the materials that we will be needing before we can say we want to do our setting out includes the item all the materials I have on this list. This list I just pulled up now shows the material needed for setting out. The first one on the list is a line. The second one on the list is a profile. The third one on the list, pegs. And the last one, nails. A line are just like a rope. They're just like ropes, like twine that you connect from a nail, define your excavation portion and your wall portion to align them on the profile. The profile are usually boards of 75 mm width, 1 inch thickness, and 3.6 meter length. Profiles are not sold in the market. They are converted from a full plank of 1 by 3 by 12 size, which is 1 inch thickness, 12-inch width, and 12 feet length. That will give you about 25.4 by 304.8 by 3.6 meters board. Now, pegs are sold in bundles. Each of the bundles contains a dozen, which is 12 pieces. Each of the bundles contains a dozen, which is 12 pieces. The nails, we need them. So let's, without wasting much of our time, let's go into how to estimate these materials that will be needed for our setting out. Line is something that is just bought as a matter of is something that is bought as a matter of proration. We buy it as much as we feel we will need it. There isn't much of a calculation needed for that. But where we have the calculation most is with the profile, the pegs, and some little calculations with the peg. Now, before we can say we want to calculate the profile and the pegs, we need to go back to the drawing that we have. We need to go back to the drawing that we have, which is this. Let me try and bold it so that the dimensions will be clear enough. Now, this is the drawing we are talking about. The length of the building is 11 meters and the width of the building is 10.7 meters. This is the building that we want to set out. If we look at the external dimension of this building, it is a square, it is a rectangle rather. It is a rectangle. Now, to estimate the profile and the pegs and the nails needed for this type of material, certain things must be considered. One of the things that must be considered is the position of the peg away from the building line. Your pegs should not be closer to your building line. If not, by the time you are excavating, the peg may fall off due to caving in of soils. So we usually recommend a distance of 1.5 meters to 2 meters away from the four faces of the building. Now, what that implies is that if this is our building, which is 11 by 10.7, which is 11 by 10.7, which is the actual dimension of our house. And I said that your profile position should be minimum of 1.5 meters away from the face of the building to prevent the peg from collapsing during excavation due to close proximity of the pegs to the excavation trench. So if we are going to be having 1.5 away from the building, it means that from the face of this building we are going to have 1.5 here, we are going to have 1.5 here. In the same vein, we will have 1.5 here, we are going to have 1.5 here. Likewise, we have 1.5 here, we'll have 1.5 here. All these positions I'm marking are representing the profile positions. 1.5 here and 1.5 here. Now, if I connect this together, I will be having a new dimension defining the profile dimension. Now this is our building. This is our building that we want to set out. So all these sides here are the actual sides of the building. Now these are setbacks created to position our pegs such that when we are excavating the trench for these building lines, this profile will not collapse due to soil caving because it is too close to the excavation trench. Now, with this being said, the distance we have between this point and this point is 1.5. Also, the distance we have between this point and this point also is 1.5. 1.5 plus 1.5, meaning that this point here and this point here, we have 1.5. That's what we have all through. We have 1.5 also. So 1.5 plus 1.5 will give us 3 meters. If we add the 3 meters to this 11, that gives us 14. It means that this our profile line from this point is 14 meters. Meaning that between this point and this point here is 14 meters. So if that place is 14 meters, because this side of the profile is parallel to this side, that place automatically becomes 14 meters also. Now we are left with the width side of the building. We have the offset between this point and this point here as 1.5 also, and the offset between here and here as 1.5 also. Definitely 1.5 plus 1.5 will give us 3 meters. If we add the 3 meters to this 10.7, that gives us 13.7. Therefore, our profile line between here, this point here, and this point here will be 13.7. So if this side is 13.7, automatically this side becomes 13.7 because it is parallel to this side. So this place also is 13.7. So now that we have our line of profile, then the next question is, how do we calculate the number of profiles that we need? We will add this line to this line, to this line, and to this line. To do that, we have 2. That is the perimeter of this profile line now is what we are finding. Therefore, profile line depicted as P/L will be equals to 2 into bracket 14 plus 13.7. Now let's pull up our calculator. And check. Calculator. So pulling up the calculator, we have the 2 times open bracket 14 plus 13.7 close bracket. That gives us 27.7. Therefore, the value we have here is 27.7 meters. No, that can't be right. Sorry, let's check the calculator. Oh, sorry, that's 55.4. Sorry about that. So this gives this gives 55.4. meters. So that is our length. That is our length of profile. Now, if that is our length of profile, how do we convert this to number of planks? If you recall that I said that profiles are not sold in the market, they are converted from a 1 by 12 by 12 1 by 12 by 12 plank that is purchased. So now, for us to be able to do the conversion, we need to check how many profile can we get from one plank. The dimension for a profile is 75 mm width by 3.6 length by 125 mm thickness. So what that implies is that if we have a plank 3.6 meter long, this side is 3.6, and this side is 0.3 meters, which is equals to 300 in millimeters. And each profile is 75 mm wide. Therefore, we are going to have four pieces of profile. In one plank. 4 pieces of profile in one plank. That is what we'll be having in one plank. Now, each one sewn to 75 mm wide. 75 mm each. So each one sewn to 75, meaning that one plank will give us 4 pieces of profile. Then going back to what we have, we realize that we have 55.4. But let us bear in mind, this 55.4 has been estimated on the assumption that the boards edges are touching each other, which is not actually the case on site. We have to consider that the board will have some lap joints, because for continuity, most times we'll lap each of the profile board We have to consider that, because if that is not considered, the material we'll be estimating may not be sufficient. For us to do that, as a matter of experience, this measurement we have here is factored, and the factor we use for it is 1.2. When you multiply 55.4 by 1.2, we'll have, let's go to our calculator. We have 55.4 times 1.2. That gives us 66.48. Now 66.48 is sufficient to cater for all the lappings that may occur while we are fixing the profile board. So that 66.48 is the value that we got here. We have 66.48 meters. Now this 66.48 now is now the new profile line that we will be converting to the number of planks that we'll be buying in the market, which we will take to the sawmill where they will cut into the sizes of profiles that is needed. So in one plank we have 4 pieces of profile, each one measuring 3.6 in length. Now the cumulative length of those 4 pieces of profile will be giving us 3.6 multiplied by 4, because one of this profile is measuring 3.6 in length. So the length of the 4, with the assumption that their edges are put together, they are touching each other, will give us 3.6 multiplied by 4. And if we press our calculator, we'll see that 3.6 multiplied by 4 will give us 14.4 meters. So meaning that this is equal to 14.4 meters. Therefore, what that implies is that one full board of 1 by 12 by 12 will give us 14.4 meter length of profile. Now with this, we can now go and calculate the number of planks that is needed to generate our profile. We can now say number of planks will be equals to number of planks will be equals to 66.48 divided by 14.4. That gives let's press our calculator, then we say 66.48 divided by 14.4 is equals to 15.4 4.61. 4.61. 4.61 pieces. But in the market, nobody is going to sell 4.61 plank to you. So you'll be buying 5 planks. So you buy that's equivalent to 5 pieces of plank. 5 pieces of plank. Now, if after purchasing that 5 pieces of plank and it is converted at the sawmill to profile, which is 75 pieces, we don't forget that one plank will give you 4 pieces. Therefore, 5 pieces will be giving us 20 profiles. 5 pieces of plank will give us 20 pieces. 20 pieces of profile. That is how to calculate for profiles. Give us 20 pieces of profiles. But it doesn't stop there. This is just one of the materials that is needed to do our setting out that we have calculated. It's just one that we have calculated, which is the profile. The next one that we need to calculate now is the peg. The next one that we need to calculate is the peg, because the profile cannot stand by itself. It is nailed around a peg. So let's see how we can get our pegs done. Now, using the same drawing that we have generated here to calculate our profile line, we consider that we will have a profile at this corner. You have another profile at this corner. You have another profile at this corner. Then you have another profile at this corner. Now, what we need to understand to calculate the number of profiles that we are going to need is the spacing. It is the spacing of our profile. Now that we have the same value that we have used to estimate our profile line, which is this 55.4, the unfactored value now, this 55.4 is what we will use to calculate our number of profile, our number of pegs, because this serves as the line of profile, and our pegs will also be nailed along the lines of profile. Now, for rigidity and durability, a minimum spacing of 2.5 spacing is specified, meaning that from this first peg, before you have another peg, it's at a spacing of 2.5. You have a peg here. Then at another 2.5 from that peg, we have another peg. And so it goes till this entire profile line is populated with pegs on which the profile board will be nailed. Now, for us to get the number of pegs, what do we do? One bundle of peg equals 12 pieces. 12 pieces of pegs equals 12 pegs equals 12 pegs. So now, if our line of profile is 55, then the number of pegs needed, which is depicted as n/p, will be equals to 55 0.4 divided by the spacing of the peg, which is 2.5. Now let's go to our calculator. We'll see that 55.4 divided by 2.5, which is the spacing of the peg, will give us 22.16. So let's get back to it. Let's give us 22.16 pieces. Now this is the exact, but we have to consider that there are some unforeseen circumstances that could crop up, like some of the pegs not good based on the wood that is used to provide it. Some may break while we are driving it into the ground, and we have to consider that nobody is going to sell 22.1. So in consideration of that, we'll factor this number that we have. Once this is factored, what factor do we use? We use 1.1. What that means is that the factored number of pegs will now be 22.16 multiplied by 1.1. What this factor does is that at 10% of everything we have, it adds it to it. And when you multiply this by 1.1, what do we have? We have 22.16 multiplied by 1.1. That gives us 24.3. That gives us 24.3. So this is equals to 24.3. Now, bearing in mind that one bundle is 12 pegs, so we convert this 24.3 to bundles. So to do that, we divide this 24.3 by 12. So if you divide that by 12, divide 24.3 by 12 divided by 12, that gives us 2.03. That means we need 2 bundles. So 2.03. That means, which is equivalent of 2 bundles. 2 bundles. That's the equivalent of 2 bundles, meaning that we will be buying 5 pieces of board, which will be sewn into 75 mm to form our profile. That will give us 20 profile boards. Then we'll be buying 2 bundles of pegs, which will be driven around the building at 1.5 meter spacing, at 2.5 meter spacing, with a 1.5 meter offset from the building around that building to create our profile line. Now, the profile has been estimated. The peg also has been estimated. But it doesn't stop there. The nails. The nails that we want to buy is a function of the number of excavation points that we have, or how massive our project is, particularly our foundation line. If we don't have too much foundation line and we don't have too much carpentry work in what we are doing, there may be no need for us to say we want to go and buy one full bag of nail and be taken out of that nail to use for our setting out. We'll only be constricted to buying what we'll be needing from the market. But if there is so much carpentry work to be done in that project, it's only logical for us to buy a full bag which we feel will be sufficient to do the job. Then we'll take the little ones that we need from it for our setting out. To do our setting out, we need 2 inches nail, we need 3 inches nail. The 3 inches nail will be used to mark the excavation point, and the 2 inches nail will be used to mark the wall point on the profile. Now, if we don't have so much carpentry work, we'll have to go and buy just what we need. And for us to buy what we need to have a knowledge of how many of each of these nails do we have in 1 kg, of the size of that particular nail, so that we won't be buying beyond what we need, though it may still be useful later, but we may need to buy what we need for that. And to do that, that is when the chart I have here in front of me becomes useful. This chart was actually obtained from a website called nailmakingmachine.net. That was why I said the credit goes to the website. The chart actually shows the number of nails per sizes, their diameter, and their number you have in each kg. The first column here shows the nail length, the varying length of the nails. The second column, that's the nail length in inches. The second column shows the nail length in millimeter. The fourth column, which is later divided into 3 subcolumns, shows the diameter of the nails, and the last column shows the pieces per kg, which is also subdivided into 3 columns. Now, let's go to the column, the ones that concerns us. We are dealing with 3 inches nail and 2 inches nail. Firstly, a 2 inches nail has a length of 50 mm diameter length, and the diameter, we have the big size of 2 inches nail, we have the normal size, and we have the light size. We're actually using the normal size, so the length of the diameter of the normal size will be 2.8 in millimeters. Now, for that light, when you go to number of pieces per kg, for that light, you have 414 pieces of that normal 2 inches nail in 1 kg, which is more than sufficient for what we need. We shouldn't be buying by more than 1 kg. Even a half kg may be enough to do what we want to do for this particular project. Then we'll go for 3 inches. Also, our 3 inches, we are buying normal. The diameter of our 3 inches normal is 3.7 in millimeters. Then we'll now go and check the quantity of it we have in 1 kg, which is 200 for the normal. Normal meaning that we have 200 pieces. So with this information, that 1 kg will give us 200 pieces of 3 inch nail, ordinary, normal, meaning that 1 kg of 3 inches is sufficient for us to do this setting out, and half kg of 2 inches, which is around 207, is sufficient for us to finish our setting out for this drawing that we are estimating for the setting out material. But this is where we'll be stopping for today. In our next video, we'll be talking about how to estimate for excavation, which is the next item we have on that list. And if you go by this list, you will know that excavation is estimated as a function of volume. Excavation is estimated as a function of volume. This is excavation is estimated as a function of volume, meaning that we will require 3 dimensions to estimate this. In our next video, we will do justice to how to estimate excavation and the principle guiding excavation estimation in our next video. Thanks for watching. If you have learned anything new, please give me a thumbs up on this video. That would encourage me to do more of the video, and the more thumbs up you give will make me to do more and to come online and come and do more for you. If this is your first time of coming across my channel, please hit the subscribe button and make sure you press the notification bell. What that does is that anytime I drop a new video, you'll be one of the first set of people to be notified that Learners Hub has dropped a video, so you can go and click on it and watch it. Thanks. Till we meet again. Goodbye for now.